Skidabrader was the very first machine engineered specifically to enhance vehicular skid resistance by an abrading process. Skidabrading is dry, environmentally clean, and safe due to its highly efficient filtration system mounted on tandem axle vacuum trucks. When loaded with debris from the surface, these trucks are changed out quickly to allow almost continual Skidabrader production during the allowable work window. The on-site transfer of this fly ash type surface material is not necessary and always contained. The material is transported off-site fully enclosed to be stockpiled for recycling back into pavement for fill or soil stabilization. Every vehicle in a Skidabrader operation is capable of highway mobilization at the legal speed limit on its own wheels, eliminating the need for loading and unloading equipment and traffic. This feature allows rolling safety zone configuration, which has the least impact on traffic in adjacent lanes. The Skidabrader has 1,000 horsepower available for the high production texturing of roads, bridges, and airport runways. It is the largest and most productive machine on the planet for this type of work. The Skidabrader's average daily production is at least 6 times greater than anything comparable. Breakdowns are virtually non-existent due to quality construction and rigid maintenance and size of our fleet. Operators must have years of both on and off-the-job training before they are authorized to take the controls. The utilization of wireless communications, a laser-guided alignment, and closed-circuit TV systems ensure longitudinal passes are as straight as the structures themselves. The Skidabrader can be in full operation within 3 minutes of arriving on the job and exit the job site just as quickly in case of an emergency requiring the full use of the road or runway. Self-contained DOT lighting allows full production night operations while traffic is least congested. The skidabrading process increases surface texture, allowing tires to grip the pavement in wet weather, reducing accidents dramatically. Water is given an escape route away from the tire footprint, therefore provides a much greater resistance to skidding and hydroplaning. Surface drainage and skid resistance are unidirectional, as opposed to the directional characteristics of grooves and scratch tines. There is nothing added to the surface to come loose and damage vehicles under traffic as there is with microsurfacing and chip seals. This process is a fraction of the cost of applied surface treatments. This dry process removes some of the softer surface matrix and its trapped contaminants to expose new sharp points of the aggregates readily available in the original mix design, returning the surface to acceptable profiles. Skidabraders recycle almost 100% of its steel abrasive material on a continual basis, but in sensitive areas, truck-mounted electromagnets are available to clean the surface or runway. These trucks sweep the surface to recover all metal objects, including pre-existing parts that have fallen off vehicle or traffic. Some Skidabrader projects are so high-profile locally that the TV news stations feature them on their nightly newscast. The Skidabrader has been shown on national TV networks such as the History and Discovery channels. Other high-profile projects over a 20-year history are verifiable proof of successful job completions. NASA engineers proved skidabrading provided the least tire wear in one of the most elaborate and expensive tests of its kind ever attempted and completed the entire 4.5 million square foot runway to exacting standards in just 8 working days. Skidabrader's patented bi-directional abrading process ensures 360-degree aggregate exposure with an aesthetically pleasing, seamless appearance. This high-velocity impact method significantly changes the color and is devoid of streaking and overlaps scarring. Noise characteristics compare very well against other pavement textures. An economical price, high production, and very minor traffic interference equal the most professional job of any competitive surface modification.